To cache or not to cache? That is the question. So caching is essentially now considered almost a necessity for most platforms that operate at scale. So in this lecture, this is the topic that we are going to cover. Uh, what kind of scenarios require caching, and when you want to cache, what are the aspects that you need to consider? So before we go into those scenarios, essentially the first thing is to understand caching, how it works, how to measure, and what are the various use cases that caching is supposed to solve. So this is a very simple diagram showing how you essentially leverage cache. So there's a user who makes a request to the backend, and the backend basically needs to get some data. Now, in a traditional scenario, the backend would actually get the data from a database or an API. But if you introduce a caching layer in between, then what the backend is going to do is it's going to first check in the cache and try to retrieve the data. If the data is retrieved, it is immediately sent. If the data is not available in the cache, then the backend would actually go make a call to either a database or to an API that is the master of the data. It will get this data back and then send it to the user. And of course, while you're getting the data back, you will also store a copy in the cache. So this is the basic simple framework using which caching operates. Now, exactly what problem does this solve? So there are two problems that caching can solve. First is throughput. So if you look at that diagram, right, basically a lot of requests will not even hit your database, or they will not hit the API that masters the data. So essentially, if there is a throughput constraint with your master, whoever is owning that data, then caching can basically solve for that throughput constraint. The other key benefit that caching can solve is response time. In general, most of your caches will be in memory, where the latency can be sub-millisecond. On the other hand, if you are caching on top of a database, the database will essentially be serving anything upwards of 10 milliseconds. And in case you're essentially getting the data from an external API, then we could be talking seconds here. So a cache can basically reduce the throughput requirement of your database or external API by essentially serving a lot of requests that do not even need to hit the master, and they can basically reduce response time significantly. When you're looking to build a cache, you should be very clear. Are you solving for throughput? Are you solving for response time? Or are you solving for both? Now, the cache does not come for free, right? It also introduces a problem, which is cache coherence. How do you ensure that the cache is kept in sync with the master? So basically, you can solve for throughput, you can reduce response time, but you introduce the problem of keeping the data in sync. So essentially, which means that you have to look at metrics, the metrics that tell you whether your cache is effective or not. So the metrics that you care about, right? Primary one is cache hit rate. So if your application made 100 requests and there was a cache, out of these 100, how many was served by the cache and how many actually hit the master database or the master API? So if you served 80 requests, then your cache hit rate is 80%. Clearly, the goal of any cache is to increase the hit rate to as high as possible. The other metric that is very important is accuracy. If your cache has served data for 100 requests, out of those 100, how many had the latest data and how many had stale data? So this accuracy problem essentially comes due to the problem of cache coherence. Again, the goal should be to have as high accuracy as possible. And there are scenarios where you have to trade off between a very high cache hit rate and accuracy. If you try to go for a high cache hit rate, your accuracy may suffer, and vice versa. Now, when you're creating a cache, you essentially have to put an infrastructure element, and you want to make sure that the cost is reasonable. So cache size is essentially an important aspect that you need to look at. How large of a cache do you need? Now, a large cache may be needed if you want a very high cache hit rate. Finally, there is this overhead, right? In some cases, you try to create uh, a lot of data in your cache in advance, essentially called warming the cache, now these requests are not coming from a users. These are additional overhead that the caching platform is creating, and you need to measure this overhead. Essentially, if a user was making 100 requests, but the caching platform needed to also make 20 requests outside of those user requests, those 20 requests are your overhead. So essentially what we have understood till now, right, is basically your caches solve for throughput and latency, but they introduce cache coherence. And when you want to look at a cache and see, is my cache doing the right job? You have to look at the cache hit rate, the accuracy, how much of a cache size are you actually consuming, and what is the overhead for warming the cache. Now we will look at these metrics in the context of three different scenarios where caches are used. These are the most common scenarios that you will encounter when you want to build a cache. The first scenario, which is essentially the most complex and clearly the most useful, is when you want to cache from an external API and you are the only consumer of that API. So if you are the only consumer of the API, then you know that all changes will flow through you. This is still a relatively simpler problem. A harder problem comes when you want to cache external APIs, but there are multiple consumers. Now, what does that mean? How can a cache or how can an external API have multiple consumers and each of them is caching their data? So look at essentially any platform that has inventory which is served to multiple marketplaces. Consider, for example, a flight. Now, a flight has a certain number of seats that are available at a certain price. This flight is available and can be booked from any of the online travel portals, whether it is Expedia, whether it is Make My Trip. Both of these platforms will cache the data so that this data can be served to their customers faster, because if you don't cache, then the data will essentially will have to be pulled from this external API, which will take seconds, and that is going to introduce latency. Now, this is a classical scenario. If you book a ticket from Make My Trip, the state would change, but Expedia would not even know. And basically, this classical scenario of caching an external API where the data is shared across multiple consumers and the state can change, this is one of the most complex problems you will encounter in terms of caching. And that is a very, very clear scenario where you have no choice but to cache because the external APIs would be slow. So in these cases, cache introduces inaccuracy. The third scenario is a very simple scenario where essentially you have a database, and because of either throughput or latency limitations, you are putting a cache layer on top of it. Now, out of these three scenarios, basically there is absolutely no reason for you to have incoherence in your cache for the first and the third scenario. Now, why do I say that, right? Incoherence means that your cache is not in sync with your master data. If you're caching from a database and your database is owned by you, any updates flow through you. So there's no reason that your cache should not be updated whenever there's an update in the database. The same thing is true for external APIs if you are the only consumer, because all changes flow through you. So you should always go and update the cache. How you update the cache and uh, and the mechanism essentially we will discuss. But if you are the controller of any updates to the master data, then there is no reason when you're designing your system that should allow cache to be incoherent. Now, For these three scenarios, the other dimension is how much data do you cache? Do you cache all the data or do you only cache the popular data? Now clearly, right, if you cache all the data, you will improve your cache hit, but of course your cache size will increase. And there will be a lot of data that maybe never gets used, but you're still keeping it. If you cache popular data, then it's basically you will have a lower cache hit, but potentially a lot more efficiency in terms of the cost. Now, these are the inputs, right? What is your caching scenario? Are you caching an external API? Are you caching a database? And how much data are you caching? The output is essentially how are you caching? What are the levers you have when you want to cache something? So there are three essential levers, right? These are the three kind of decisions that you need to take. When do you populate a cache entry? Do you populate it on demand or do you pre-warm your cache by prefetching the data in advance? The second question that you need to answer is when do you expire a cache entry? Do you expire a cache entry when it becomes old or do you expire a cache entry when basically the data changes and you know that it has changed? And the third is when do you update an existing cache entry? So you can do it when there is actually an update and you are on the path and you realize there's an update. Or you can update it whenever there is a cache miss, or you can update it when you think the cache has become old and it's stale. So basically, when you're trying to design a caching solution, you have to look at your scenario, which is on the left hand side, which is what are you caching, to how are you caching. So when do you populate, when do you expire, when do you update, based on the scenario that you are talking about. So the first scenario that we will cover is when you have an external API that you want to cache and the external API is shared. So not every change will flow through you. In that scenario, it is never practical to actually cache all the data. So for example, if you look at the Make My Trip and Expedia example, it is never a good idea to cache data for every possible sector, for every possible flight, because you will not see a lot of traffic for them. Things will change, you will not even know. And essentially, there's this problem of a huge cache size as well as a cache coherence problem that becomes very hard to solve. So in general, if you're looking to cache external APIs, you should be caching only popular data. So now let's consider that scenario that there is an external API. Assume that there is essentially a flight operator. Let's assume it's Lufthansa, right? So Lufthansa has a lot of flights, lots of sectors, and Make My Trip and Expedia are trying to cache that data, and they're trying to cache the popular data. How should they decide when to populate something in the cache? Clearly, you have to look for a trigger which says, oh, this data is popular and should be cached. And the trigger for that is actually usage. So essentially, which means that it should happen when there's a cache miss. And that's exactly what you should be doing. You should only populate the data, populate an entry in the cache when there's a cache miss. When do you need to expire? Can you choose not to expire and only update when you have a booking? Not really, right? Because you don't control that data. So the data will become stale and you will not know that something has changed. So all caching for an external service that you do not control has to expire at some point in time, whenever you think it is stale. And now that definition of staleness is where most of your effort will come into. The simplest approach people do is basically put the same TTL or time to live for all the entries in your cache. Now that doesn't work, right? Because some sectors, right, in our example, would actually change faster. Some sectors would change slowly. So basically, you will either end up with a very aggressive TTL or a very conservative TTL. So, but the bottom line is that you still have to expire data based on TTL. Now let's look at when do you want to update your cache data. You want to update your cache data whenever there's a write, right? So basically, if there's a write, you know that, okay, I am updating the data. So the data has become stale. So basically, let me go and write it. But you also need to update when stuff has become stale. So let's say there was a popular data and it expired because the TTL went out. Now you want to go and update that data to something more recent. before you have a cache miss because it's popular data. So you don't really want to wait. So the way you're going to implement this is basically whenever you get an expiration on your cache, then you basically go fetch it from the target and essentially get the data back. Scenario two, right? If there's an external API, but basically you own it and you're trying to cache all the data. Then you'll have to prefetch, right? So you'll have to prefetch, and because you don't know what data you will get now, and so you'll have to prefetch everything. The data will never expire because everything flows through you and you will update when it's written back. If you want to only cache popular data, then you do not prefetch. You only update it on cache miss, and basically you will expire on TTL because if something is not touched for a while, it means it is no longer popular. So that is how you will basically churn out the data that is no longer popular, was popular at some point in time. And then of course all writes flow through you, so all writes become updates. The database example, when you're caching on top of a database and an external API that you own, are very similar. And that's why the levers that you will basically apply are identical. If you're caching all the data, you will prefetch or bulk load. You will never expire the data and update on writes. And if the data is, you're only caching popular data, then the only difference you're going to make is basically don't prefetch ever and expire when the data is no longer used for a while. So if you look at basically uh, our table, right? Basically, we are updating on writes. Now, this update on writes is needed for you to ensure that your caches are coherent. And this is true for like scenarios 2, 3, 4, 5, right? Because in all these cases, there's a crime for your cache to not be coherent, right? Everything is flowing through you. Why will you not keep your cache coherent with your master? And the way you want to keep your cache coherent is actually in an async fashion. You want to make sure that there's update stream coming from your master, and that from that update stream you go and populate the cache. You should not try to actually create a two-phase commit kind of a solution in your application where you try to write both to the master and the cache, but instead try to create an eventually consistent update stream that will ensure your cache is always coherent with your master. And again, note that this is something you cannot do if you do not control the master, and there could be updates that flow through to the master without you being aware of it. Finally, right, when not to cache, right? Should we always cache? And I think one of the fundamental challenge I see is that a lot of people always put a cache layer, which is something you don't need to do in many scenarios. For example, if you're using a NoSQL database like a Dynamo or a MongoDB, right, and it is scaled well or it is serverless, you don't have a throughput problem. You also don't often have a latency problem. There are very, very few scenarios where you need a sub millisecond latency. In most applications, the latency that a Dynamo gives you or a MongoDB gives you for a reasonably sized query with the right indexes is good enough. So if you are using a NoSQL database, you don't have a throughput constraint, you don't have a latency constraint, don't put a cache. You should also not put a cache if you have a very large data set which doesn't have any popular part. So you're basically people are going through the entire data set. So if you cache, you will have a cache with a very low cache hit ratio. This is again a very common problem. People create a cache, they don't even measure the cache hit ratio, and then when you actually put a measurement, you realize it's 20%, which is not solving either throughput or latency. And the third scenario when you should not cache is when you have very, very high update rates. If you have very, very high update rates, and especially if you are not the master, right, then your cache will have huge incoherence. Your accuracy will basically be very, very low. Even if you are the master and you have very, very high update rates, all updates will need to basically flow to the master, and there is hardly any throughput you're saving, right? So basically very high update rates, very large data set without a clearly defined popular set, and caching on top of a NoSQL database without a throughput or latency problem, right? Those are the scenarios when you should absolutely not cache. When you really need to cache, then you can apply the techniques that we have talked about.